Hi, welcome back to Musin Chemistry. This is electron configuration of Rhodium, RH. Well, Rhodium happens to be element number 45. All right, so we're going to put a 45 right up here. And its atomic mass unit is going to be 103. AMU is 103. So we're going to have 45 protons. To be electrically neutral, we'd have to have 45 of these. What about our neutrons? Well, we go AMU minus protons equals neutrons, right? So you go 103 minus 45 equals 58 neutrons. Pretty darn snarly. So we're going to write 58 down here. Cool. Now we're going to clean up some of this mess. Get rid of this excess right here. Because we definitely need the space. Alright, so now let's get back to this. So remember that S subshell can hold 2 electrons, P subshell can hold 6 electrons, D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. We're going to talk about the off-ball principle. That means we fill the lower shells first before we fill the upper shells. Okay, and we're going to use the diagonal rule to emphasize that. I like that word, emphasize. So we'll start off with 1s2. Let's go for it. 1s2. 2s2, 2p6, 3s2. I have to warn you, this is an exception. 3p6, 4s2. 3d10, 4p6. So let's slow down here. 3d10, 4p6. Then it's going to become 5s1, 4d8, because the energy levels in the shells are very similar to each other, so they tend to jump around a lot. Okay, now, again, exception, you've got to be careful of, let's say, ruthenium, rhodium, palladium, and silver, and also rubidium too, all in that N4 level. Those you've got to be really careful. All right, so now, Hund's rule states that you have to put an up arrow before you put a down arrow in every suborbital. So let's go do that. There we go. And here's a good example. 2px, 2py, 2pz. I'll start the down arrows. Notice that. It's looking pretty snarly, huh? There you go. See how I'm doing that? It's looking pretty good, eh? That's right. 1, 2, 3, 4, and 5. And then 4px, 4py, 4pz. Now be careful. Here's your 5s. It's an exception. Here you go. 6, 7, and 8. Wow. Okay, what is rhodium's noble gas notation? Well, the nearest noble gas state is krypton. R. So now let's get the valence shell, which is right here. Here's our valence shell. Okay, so it's going to be 4d8. 5s1. Now, what about our quantum numbers? Well, remember the Pauli exclusionary principle says that no two elements can have the same set of quantum numbers. All right, no problem. Okay, so we're going to look at our n number first, our principal quantum number. It looks like it's in period 5, but remember that rhodium is in the D block, which is n minus 1. So you would go 5 minus 1 would give you 4. Ooh, so 4 is our number. Cool, huh? Now, let's look at our LVAD. Our angular momentum number is going to be 2. It's in the D block. Now, what about the magnetic number? Well, let's count these over. -2, -1, 0, 1, 2, minus 2, minus 1. It's going to be minus 1. And then let's look at the last arrow, which is right there. It's going to be 1/2 negative for our spin number, right? Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.